straightforward at the beginning. It's probably not going to be that complicated. I do want you to get in the habit, though. We're going to be checking our answers every problem with our calculator. And I'll explain more why we're checking our answers in a few minutes. But for now, we'll just make sure that we have our calculator out so we can get in the habit of checking our work. So if I have a, which is the square root of x minus 3 equals 5, what do you think I have to do first in order to solve for x? Do what? Move the 5? No. Only x by itself. What do I have to move? The 3. But can I get to the 3 yet? It's under the radical. No, I have to move the radical. How do I do that? We're going to square both sides. So that's your first job on this problem. We're going to square both sides. That square and the square root are inverses of each other. So all we have left on the left-hand side is x minus 3 equals 25. So then we have access to the radicand. So you're going to add 3 to both sides. And you get x equals 28. So, well, that one was easy. I know they're not all that hard, but there's more to it. But like I said, we want to get in the habit of checking our work. And my suggestion is you use your calculator. So there's a couple ways to do this. I would just take your calculator and type in exactly what the problem was, which was square root of. Now, instead of x, we're going to check our x of 28. So you type in 28 minus 3 and hit enter. Now, I know you could do that in your head, but you get the answer of 5. And is that the answer that they gave you on here?
Yeah.
Yes. So you know that this is correct. And again, I will get to the point why we're checking our answers in a couple of minutes. But for now, we're just going to check them to get in that habit. All right, when I look at B here, what do I have to start with? The 3. So the rule is, and it might be a silly rule to you, but I do this in my Algebra 1A class when we're solving things. We're going to call it like a radical bubble there. I cannot deal with the radical until everything outside of the bubble of the radical is dealt with, which means I have to move the 3. And since it's being multiplied, we have to divide by 3. Okay? So you have the square root of x over 2 equals 5. Now we are able to deal with the radical. We square it, which gives me x over 2. Equals 25, and then how do I get x by itself? Times 2, which is 50. Okay. So again, you need to check your work here. So we're going to type into our calculator 3, write the square root, and instead of x, we're going to put in 50. So 3 square root, if you have the capability for a fraction, type that in, we'll do 50 over 2. Which gives you 15. Is that the answer that we wanted to get? Yes. Okay, so we know that 50 is the correct answer. So let's do the last one here that's more complicated, and then we will move on to why we're checking our work every time. 5 times square root of 3x minus 2 minus 4 equals 36. Where do I start this time? Plus 4. Yep. So I don't deal with anything under here until I start by adding 4. So I have 5 times the square root of 3x minus 2 equals 40. And you divide by 5. Square root of 3x minus 2 equals 8. And then the same process, you square both sides and just deal with what's underneath. 3x minus 2 equals 64. If I add 2 and then divide by 3, what are you left with here? Ooh, not 11.
Oh,
22. Yep. So again, you'd want to check your work. So you would type 22 into that equation. Now, when you do check your work here, this is a simpler problem. You want to make sure that when you put this in, so you have 5 radical 3 times 22 minus 2. It's all under the radical, but when you do the minus 4, you have to arrow out of the radical. And that's what we started with, right? All right. So that's all. That's easy, right? Not hard. That works. Not hard to do. The more challenging stuff happens when you end up having two equations like this. So we have the square root of x plus 3 and y equals x plus 1. We're going to consider that as a system of equations right now. So a system just means you're solving two equations at the same time. So we're going to solve this by graphing first. So you're welcome to use your calculator to graph this, but these should be pretty easy equations to graph, especially after the quiz we just had. If I'm graphing square root of x plus 3, what transformation happened here? This one went left 3. So, again, you can use your calculator, but let's take a minute and take the parent function and shift it left 3. If you're not sure how to do that, then you can use your calculator. Shouldn't end up there with your parent function, just shifted left 3. And once you do that, once you're done, I'll give you a minute here. Then you can graph the line y equals x plus 1. Again, you shouldn't need your calculator for y equals x plus 1. But go ahead and plot that line on the same grid. Kind of a curvy line, but that's okay. Now, when I look at a system, when I solve a system by graphing, how do I actually find the solution? What feature are you looking for? You're looking for where the graphs do what? Intersect. Well, what ordered pair does that intersect at?
1, 2.
1, 2. So what is the solution? What number do we use for the solution? The x or the y? The x typically. We're trying to find the x. So our solution here is that x equals 1. That is where the value, the y value, is the same. So let's pause on the graph part. Let's solve this algebraically. Okay, so the way we're going to solve this algebraically says use the method of substitution. All that means here is let's set these two guys equal to each other. All right, so we're going to take the square root of x plus 3 equals x plus 1. All right, how do you think we should go about solving this here? What makes sense to you? Square it. Yep, we're going to square both sides. Now here's where you have to be careful. When I square the right-hand side, I actually have to square the whole quantity, x plus 1. So you end up with x plus 3 equals x plus 1 times x plus 1. It's our favorite thing. We have to double distribute. We've seen this a lot this year. So let's simplify the right-hand side. Go ahead and multiply that out for me. And then tell me what you get. So take a minute. You can do it in your head. You can write it down. X squared plus 2x plus 1. Good. You probably see where it's going here. Are we okay with that? You can probably see where this is going. What should I do next? Move the x plus 3 to the other side because we're probably going to end up having two factors. I'm going to move both of those terms at the same time. Minus x and minus 3. It's our favorite thing. Factoring just doesn't leave us alone, does it? So we cross those off. I get 0 equals x squared plus x minus 2. That one's at least a nice easy one to factor. What should you do here? How does this factor? Yep, plus and a minus. And what number should I use? 2 and negative 1. Yep. So what solutions do I actually get here? Negative 2 and positive 1. But part C asks us a question. Does that answer match what I said in part A?
No.
Why not? I have x equals negative 2 and x equals 1, and up here I only have x equals 1. So why does our answer from the part A contradict what we did by factoring? Dean? Yeah, basically, the graph here only intersects at one point, right? And that solution that I just found by factoring said it intersected twice, but the graph proves me wrong because the square root, like Tegan said, the domain just stops. So what we can say is, let's see. graphs only intersect at x equals 1, not x equals -2. So here's the problem. And it looks like when I solved this by hand, I got an extra solution. Ready? So flip your paper over. That extra solution is called extraneous. Right? It has the word extra in it, but basically what that means is sometimes when you solve things algebraically, you just get extra numbers. So you have to be able to discern which numbers are the actual solutions and which ones aren't. That's why we keep typing our solutions into the calculator. So let's actually skip to B. I'm going to skip A. I'm going to shorten this even more for you. We'll just do B and C here. So when I look at B, I need to solve this equation. So let's see what this looks like. Well, what should I do first here? Add 2 to both sides. Right, so I'm going to do plus 2 on both sides. And I'll end up with 2x plus 2, bless you, equals the square root of x plus 6. Now this is similar to the last problem. What should I do next? Square both sides. And when I square the left-hand side, you need to remember that we are multiplying 2x plus 2 times 2x plus 2. So you need to double distribute. And again, I don't care if you show me all the work or if you do it in your head. I typically do put my answer keys. I did it all in my head. This would give me 4x squared plus 8x plus 4. And then just like the first problem, I'm going to subtract over the x and subtract over the 6 so that I am set equal to 0, which is going to help me factor here in a minute. So I'm just going to come up to the right here. So what do we have? 4x squared plus 7x minus 2. What method do I have to use to factor this one? Split the middle. So what are 2 numbers that multiply to -8 and add to 7? Bless you. Positive 8 and -1. Okay. So let's go ahead and split the middle. You can work ahead of me if you need to. But in case some of us are still a little rusty on our factoring, you split the middle up with the 8x and the -1x. And you use the method of grouping. So put the first 2 in a group and the last 2. Bless you. Oh my, are you allergic to solving square root functions? Seems like it. That's how I was on Sunday. My allergies were really bad and I just could not stop sneezing. Alright, we pull out a 4x here. And what's left when I factor out a 4x? X plus 2. And what's the GC after the other group? X plus 2. Alright, so we got our factored form of 4x minus 1 times x plus 2. Anyone have a problem with that factored form? No. Alright, what are my solutions when I use my 0 product law here? X equals 1/4 and x equals -2. Now here's the problem. When I am doing these problems now, those are either both going to work, one of them is going to work and one's not, or neither of them are going to work. So this is why we need to check every answer when we use, when we solve these square root functions. So we have 2 ways of doing this problem. The first way is that we can graph these 2 equations and then see where they intersect. If they intersect at those x values, then it's a solution. Or you can just type the numbers straight into your calculator. Which method would you like to use? You want to do the graph? Okay, we can graph. So here's what we do. If we're going to graph this, and I can show you the other way too. We're going to type in 2x into our y equals on one line. And then you're going to type the other line, the other y equals, to be square root of x plus 6 minus 2. So the square root of x plus 6, arrow out, minus 2. thing you can do also while I'm in the y equals, so before I hit, I'll hit graph here first. So you see, first of all, how many times do those graphs intersect? Just once. So we know at least one of our numbers is going to be extraneous. So I can go here and I can hit second trace. I can hit number 5, intersect. And all I have to do is hit enter 3 times by that intersection point. And you see what? Where do they intersect at? 1/4. So it looks like 1/4. You can go ahead and circle that one. That is your solution. Go ahead and cross off -2. Now I'll show you another reason why. Here's another way you can check that. On your calculator, another way you could do this is to go to the table. If I go to where x is -2 right here, what do you notice about these y values? They're different. That means it's not a solution to both. You could also, if you didn't want to graph it, if you came out to your main calculator screen here and you typed in 2 times -2, that was the left-hand side of my equation, right? I put -2 in for x. You know you're going to get -4, but I'm just going to show you here. And then if I put -2 under the radical, so I have the square root of -2 plus 6. And I know you can do this in your head, but I'm trying to show you here. -2, I got 0. Since those two answers are not the same, that's why -2 is extreme. Okay, we good on that one? Let's look at the last one here. One more problem. What should I do first? Squared. Square both sides. So I'll get x squared. This one will be a little faster. Plus 12x plus 36. What's -6 squared? 36. All right, well, this one actually works out pretty nicely because I just moved the 36 from the right-hand side here to the left. And what happens when I subtract it? They both go away. So you end up with x squared plus 12x equals 0. And what factoring method are you going to use? GCF. So I pull out a GCF of an x here, and I get x plus 12 equals 0. What two solutions do I get? 0 and what? -12. All right, so we have to check these. So here's what I would do. You can use your graph, which we're going to look at in a minute. But let's start by just typing it right into our calculator. Let's put 0 in for x, because since it's equal to -6, that's really easy to tell right away. All right, so when you go here, let's do our square root of, so instead of x squared, we'll do 0 squared plus 12 times 0, which I know is easy to see, plus 36. But when I hit enter, I get 6. Is that what we were equal to? No. It's said to be equal to -6. So that means 0 is not an answer. 0 is extraneous. However, you can't just assume that -12 is going to work. You have to check that -12 is your solution. So let's type -12 in for x. So -12 squared plus 12 times -12 plus 36. And when I type that one in, I get 6 again. So is -12 a solution? No. So that actually means here that both of those solutions are extraneous. So is there a solution to this problem? No. What symbol do we write when there's no solution? That empty set symbol. All right, what do you think that means about the graphs? If I were to graph both of these, they don't intersect. So you'd have x squared plus 12x plus 36. If I graphed y equals -6 here, why doesn't it like me? Hold on. Oh, I used a minus sign instead of a negative. There we go. Do those graphs ever intersect? No. So that's why there's no solution. All right, we got so far? That's it for today. There's some problems on the bottom. If you are so inclined